Is this running? Okay, seems to be running. All right, so we're going to start working on a little asteroid game in a very interesting framework that is completely web-based. So notice this URL here, codesculptor.org, right? This is a website that is used by Coursera to teach Python to beginning programmers, beginning coders. And it has the advantage that it's completely web-based and um, nothing needs to be installed on your computer. Nevertheless, it has the disadvantage that you can only import the packages that are already preloaded into the website. You cannot install anything external. Um, so, how does this work? All right, so I'm going to start by just um, um, opening a completely new workspace. This workspace is, uh, I mean, whenever you open the site, there will be an initial piece of code there. I will show you what that code is doing, but I just want to show you the bare Python first, right? So we can start something very basic here. For instance, def, we have square sum, right? We take two numbers, a, b. This is the Python that we know. When we say return a times a plus b times b, this is one of the first procedures that we have written. And then we're going to have a print the square sum of 3 and 4 is, and we're going to have square sum 3, 4, and then we can run by pressing this button here in the website, and then we have a result, which unfortunately this is the result for Python 3. So what I'm going to do is I'm going to copy all this code and I'm going to follow this link, which is py3 codesculptor.org, and we're going to write in our usual Python 3 where, all right, by just pressing run, we're going to get the output, right? So you see now that the output is separated from the input, right? We can run entire files. We can take any of the files that we have written so far and run them here. Probably the one that has graphics will not work. Now, if we open a completely new tab, and we just use the initial code that is given here, we get this little window opening up, right, which shows you that this website has the ability to do graphics, right? It has a little area for controls where we can write our own controls, and it has an area where we can print some graphics. All right. Let's try, by looking at this sample app, let's try to understand how this framework works. All right. So the package that performs graphics is called Simple GUI. All right. And let's ignore these procedures for the time being. Right. In order to get the graphics to start, we create what we call a frame. All right. The principle of performing graphics, of drawing graphics, is relatively simple. Um, um, there is an underlying piece of code that we do not control and we do not see, that takes what we call a frame and displays it on the screen with a certain frequency. A very typical frequency is 30 times a second, right? So what we do is we write a piece of code that generates a frame, and then we wait for that frame to be displayed on the screen, and then we draw the next frame, and then again we wait until it is displayed, and so on and so forth, right? You have to understand that 30 times a second in terms of computer time is a very low frequency, right? You get about 30 milliseconds of time to draw something. That is a very long time. You can do a lot of stuff in that time. So what we do here is we have to initialize an object that represents the frame, all right? And we create controls. We're not going to do a lot of controls. We might do a little bit of controls initially just to play with, but we won't. And then we set up this procedure to be invoked 30 times a second, right? So by this line here, we're saying this procedure called draw, which is the one that is defined here, will be invoked 30 times a second. And then we start the animation. At the point when this line is executed, the little extra window shows up, right? And the drawing is displayed. How do we create animations? Well, we make this function draw something else every time, all right? And we're going to see how that works, right? But for the time being, let's try to understand the current code, right? So one important thing to understand when we talk about animation is the fact that we are reactive. We are not writing the main program anymore, right? The main action is in these procedures which are submitted as event handlers, right? Whenever an event happens, this procedure is invoked, right? So we're saying whenever somebody clicks the button, execute this. Every time we execute this, right? Whenever a new frame is about to be displayed, execute this and draw the frame. Draw inside the frame, right? So the frame gets drawn, and after that it gets displayed on the screen. And as soon as this ends, the draw is invoked again. It draws potentially a new frame, and then that frame gets displayed. All right. So we are telling the framework, this website, that this is how we want to handle the execution of our code, right? So whenever we run, right, you see this. If I click here, we're gonna see good job, all right? And even though this message appears stationary, it is actually drawn 30 times a second, okay? We have several options here. We can expand it. Nevertheless, remember that the size of this will be always fixed, right? We can shrink it back, we can close it, all right? How do we get the size of the window? We get it from here, right? So one thing that I'm going to do is increase this size to 800 by 600, all right? And then how does this message get drawn, right? Let's explain how the program works first, right? So we have this button, which is called click me. Whenever we clicked it, this a procedure has been invoked. This procedure is here. What does it do? This procedure changes the value of this string. This string initially was welcome, and then it became good job. Whenever we have executed click, we change the message to become good job. This is invoked 30 times a second, right? And it prints whatever is inside the string message. So as long as message was welcome, you would see welcome on the screen. As soon as the button was clicked, then this is executed, the message changes, and then this function will display a different thing. Now let's try to animate the message on the screen. Let's try um, to draw it in a different place every time, right? So how are we going to do this? Well, I'm going to start with a two variables called x and y. So I'm going to start from the same place where it is now. X is 50, y is 112, right? And then every time I start from x and y here. All right, this is the size of the font, if you're wondering, right? And this is the color of the text. We can make this maybe a bit smaller. And then after drawing, let's move the text a little bit. So I'm going to say x is assigned x plus equals 1. So x is incremented by 1. And y is incremented by 1. And then because x and y are outside of the function, we have to tell this function, this procedure, this method, we have to tell it where to find the x and y, right? And we do that by saying global x and y. Notice that the same was done here, right? Message is outside click, and we have to say that message is global. All right, so how do we save this? I'm going to press Command S. On Windows, you probably press Control S. The other thing you can do is press Save. Notice that once you press Save, the URL here has changed. All right, so this becomes the unique link to identify the code that you have just saved. So the website will keep this version of your code, and whenever you're going to put this into your browser, it's going to bring back to here, right? So every time you save, you have to be careful to take this link and save it somewhere, right? And we are going to exchange these pieces of code with each other by exchanging these links, right? So we're going to do the asterisk game. Assignment 4 is going to be based on the code that we end up writing in class. And I am going to pass that to you by giving you the link that I have just saved. So let's run now this code and see what comes out. And you see now that we have a larger window, which doesn't fit fully on the screen, unfortunately, it looks like. And you see the text running down. So what if I say here 580, I save it again, I run. It seems that the window is still, okay, 590 is probably a little bit better. I wonder if there's anything I can do to... All right, so I'm going to close. I'm going to try to click on the click me button very quickly, right? If I do it now, you see how the text has changed while it's still moving around, yeah? Because whatever the string contains is what will be displayed. All right. We can this will make it go on a diagonal downwards, right, until it exits the screen. And you notice that the program doesn't end, right? So in principle, this canvas that we have here, which has the size 800 by 580 right now, expands infinitely. And what we see on the screen is just a viewport to this canvas, right? So the system will continue to draw it at the coordinates that are current. If those coordinates are outside of the viewport, it will simply um, uh, you will not be able to see it on the screen, but the program continues to run. All right, so it is our responsibility to make sure that whatever we draw is within the limits of the visible viewport into the canvas. So let's try to do this on a slightly um, on a slightly different um, on a slightly different trajectory. Um, so I'm going to uh, no longer specify initial values for x and y, right? But I'm going to have a center at, say, 100 and 100. And I'm going to have a radius, right? And I want to move this text on a circle, right? So I want to have a radius of maybe 50. And I could save 150 here. All right. So I will have an angle that starts at 0, right? And we will increment the angle by a certain amount all the time. Remember, angles are measured in radians, right? So this is going to be, sorry, in radians, right? Incremented by pi. So something like pi divided by maybe 60, right? So it'll take 2 seconds to, it'll take about 2 seconds to go into a full circle. All right, so global XY. So let's not have a global XY anymore. We're going to have a global angle. All right. And how do we compute the X and Y if we have the center and the radius and the angle, right? We're going to have X equals, right? Center, so the X component of center is center 0, right? Plus radius. And on the x-axis, we're going to have cos, the cos function, angle, right angle. And then for y, we're going to have center 1 plus radius times sine angle. All right, we're going to draw the message at x and y, right? And then let's increase the angle. Equals pi divided by 60 might be too much. Maybe pi divided by, because the full circle is 2 pi, right? So let's try pi divided by 15. Pi divided by 15. All right. So now we need to import a few things, right? So we need to import math. So from math, import pi sine cos. All right, and we're going to save, and let's try to run. And oh, pi divided by 15 is way too fast, right? And if I click, it's going to become good job. I'm wondering whether the animation is too fast for sharing over Zoom. Let me know. So let's go back to pi divided by 30 here. And run again. And this is a bit better. Yeah. This is a bit better. So this is how we do animation, right? Let's explain again what is happening here. Once I click me, I'm getting a good job. The strange thing is whenever I click on that, I will get a little glitch. And now I kind of lost the other buttons. reset this? Okay, if I reset it, goes away. So what did I do? I pressed run. So if I see, so I can actually push it up. In which case, if we do this, we can actually go back to 600. Sorry for the detour. I just want my 600 back. So I can put it here. Sorry about the phone. Somebody else will answer it. Okay, so we have our animation. Oh man. All right. So what's happening here? Again, right? So we have a frame, right? We are telling to this frame how to handle events. So whenever we have a click on the button, we invoke this function. Whenever a new frame is about to be drawn, we use this function, right? So this function will be invoked 30 times a second. Every time this function is invoked, right, we print the text at these coordinates. And then we increase this angle. All right? And this angle will go to infinity. Remember that the sine and the cos functions are periodic on 2 pi. So sine of angle plus 2 pi is equal to sine of angle, right? So sine will always stay confined between 0 and 1 as cos will do, right? We just increase this angle, and then 1/30th of a second later, this is invoked again, right? But these coordinates have changed a little bit, right? This value changes as well, right? So we're drawing the text in a slightly different place, right? And this will give you the illusion of animation. It's just a succession of different images being placed on the screen in very quick succession. Seems that we have a, well, 30, so the question is why 1/30th of a second? It's 30 frames per second, right? Why 30 frames per second? Right? So it's 1/30th of a second. Yeah. Why 30 frames per second is the television standard. It's called NTSC, I think. It's not really important. In order to keep the illusion of animation, they have to go in front of your eyes pretty fast. I think the slowest they can go is 15 frames a second. And you can actually control that. So various game controllers will have ways of controlling the frequency with which things are being displayed in front of your eyes. The quality of the animation seems better if the frequency is higher. So I think very modern television sets would have maybe 100 frames per second. Anyway, that's a completely side issue, right? So this number, I'm actually guessing it. The 30 frames per second, I'm actually guessing it. I'm not sure it is what it is. It's fixed inside this web application, and it's not something I can change. But it's important that it's pretty smooth. It looks like a pretty smooth animation. All right, cool. So one thing that we can do relatively easily while we're still practicing is to draw a bouncing ball. All right, so we're going to start a completely new project that is a bouncing ball. I'm going to go here and delete. So I'm not gonna keep this. It is in the recording. You can actually take it and copy it if needed, but this is a piece of code that is not so consequential. So I'm going to go back to here, and I am going to start from scratch, but not completely from scratch, right? I still need this stuff, right? For the time being, I'm not going to use the click. So I'm going to leave the click. And then I'm going to delete it, click, right? And we're not going to draw text. We're going to draw a ball. Um, how do we know what we can do in this framework? Well, we can hit the docs. All right. This is a very specialized and very non-standard, Python sort of website, right? There are standard ways that are similar to are actually using what we have learned so far, right? But they would require the import of a package called Python game, and then these imports of packages they work in different ways on different computers. And if the class, since the class is not happening physically, I don't trust that each of you will go successfully through installing the Pygame library, and therefore I opted for this option. I can demo the other way of doing things when in class, and we can try it, and I can help you install the Pygame library. But for the time being, let's just stick with what we have. So we're going to be so there's a documentation here. The documentation is very good, very comprehensive. Again, this is an app. This is a web app that is used by Coursera in teaching Python, and because of that, it is very well put together, right? So we're looking at Canvas and what we can do in a Canvas. Well, apart from drawing text, which we have already experienced, we can draw lines, we can draw polygons, we can draw circles. We can draw a bunch of other things, right? But for the time being, what we want is to draw circles. So let us learn how to draw circles. So what do we have here? We have drawing canvas.draw circle. So this is the method that is being called. It is inside an object called canvas, and also we are importing simple GUI, which means that we might actually have to use simple GUI in front of it, right? So we're drawing the circle, and we need to provide the center. We need to provide a radius. Yeah, center point, a radius, a line width, and a line color. And optionally, we need to provide a fill color. And we're going to pick the fill color and the line color as being the same, right? Or maybe not. Let's just experience it in full in its full flexibility, right? As a method for drawing. Notice that colors are very straightforward to produce, right? We just write them as strings. So let's try to draw a circle that represents a bouncing ball, and when it reaches the boundaries of the viewport, it reflects, it bounces, right? And it stays within the visible area. So we're going to go back here, all right? And we're going to have outside, we're going to have, as before, a center, and we're going to take the center as we want, and let's be generally a little bit more methodical about how we develop programs. So I'm going to have a width that is 800, and I'm going to have a height of the viewport, which is 600, and then I'm going to have 800, oh, I'm going to have, sorry, width here and height. So if I want to change my mind later, I can do that. I'm going to have a center, which is going to be at width divided by 2 and height divided by 2. And then I am going to have for the beginning, we're going to just move the ball on diagonals, and it's going to just bounce, and the speed is going to be 1 pixel per frame. All right, so let's go here and say that canvas, and we want to draw circle. All right, so let's remember exactly. Draw a circle. So we have a center, radius, line width, line color, and fill color. So we're going to have the center here. Radius, so let's set the radius of maybe 30. All right, so this is going to be the radius. Then we're going to have a line width. I'm just going to say 5 here. We're going to have a line color, so let's say red. And we're going to have a filling, which is yellow. All right, and let's check that everything works for the time being. So I'm going to save, and then I'm going to run, and we see the circle with a border that is of red color and a width of 5 pixels and a filling of yellow that we have inside. And we can close this, all right? And then we can actually say, instead of, so that's the center, all right? And the center will move. So we're going to have global center, all right? And we're going to say that center becomes center 0 plus 1, 1 plus 1. And let's see what happens at that point. All right, so if we run the code this way, we're going to see that the ball is slowly moving until it exits the screen. All right, in order to allow it to bounce, we need to do 2 things. One is we need to detect when it has reached the boundary, or it has reached the limit of the viewport. And 2, we have to allow it to move either down or up, and either left or right. So we're going to have 2 types of velocities, right? Velocity x, which is initially 1, and velocity y, which is initially 1 as well, right? So instead of moving the center to velocity increasing it, right, moving it to +1, we're going to move it plus vx plus vy, and then we're going to detect the boundaries and check the change the vx to be minus vx. So vx becomes -1, or vy becomes minus vy, right? So when this is happening, I'm going to have global center, global vx, vy. All right, so I am going to start checking if center 0, right? So if center 0, which is the position on the x-axis, on the horizontal direction of the ball, is at the left boundary. So how do we know it is at the left boundary? We can't check against 0, right? Because this 0 is where the center would be, right? So in order for the border of the ball, for the outer part of the ball to be touching the left side of the viewport, it means that the center has to be at a distance equal to the radius, right? So if center 0 is less than or equal to the radius, it means that the ball is already touching the left side of the viewport. So if this is happening, then we have to change the velocity. Vx equals minus Vx. Yeah. But when do we also have to change the direction? When we are at the right side. The same thing happens, right? All we have to do is change direction, and this is universally the instruction, the command that creates the change of direction. If we were moving left, we're gonna move right from this point on. If we're moving right, we're going to move left. So we here can just check if center 0 is close to the right side of the viewport, right? So when is it close to the right side of the viewport? If center 0 is greater or equal to width minus radius. So again, if the edge of the ball is touching the right side of the viewport, then the center needs to be radius pixels away from that, right? So if the edge is at width, the center is at width minus radius. So we have to perform this check. Yeah. And then similarly, we have to do that for up and down, right? So if center 1, which is the y direction, which is the vertical direction, right? If it's less than radius, right, it means that we are touching the top side. By the way, unlike in mathematics where the y-axis grows upwards, here the y-axis grows downwards, right? So higher values of this coordinate means that we're further down on the screen. So we're going to have Vy equals minus Vy, right? I'll answer the question in a second. And instead of width, we're going to have height. And let's try to space them nicely. I'm going to save and let's see what the question is. How do I get the questions? Okay, here. It should be or instead of and. Very good. So I'm not quite sure what I did here. It should be an or. And it should be an or. All right, so let's run this. And then you see it bouncing. So a velocity of 1 pixel is quite slow. All right, so what can we do? Well, obviously one thing we can do is make it run a lot faster. I can say 5 here and 5 here, and that'll make it a lot faster. Yeah. It will be interesting to actually speed it up with a button. All right, so let's try to add a button that can speed up the ball. All right, so we're going to use this frame add button, click me, but we're going to say that the title is speed up. And we're going to do speed up here. And we're going to define do I have to do anything here? how did this function look? Okay, no arguments. Yeah, so we're going to go back. So there's no arguments. So we're going to do vx global vx vy, and then we're going to do vx. So we're going to speed it up by 2. Vx times equal to vy times equals 2. So it doesn't matter whether it's positive or negative, it will just increase in magnitude. We're going to start from 1 again. All right, and let's see how this goes, right? So now we have a speed up button, and then notice how as I click, it becomes faster and faster. And you can try to, you may want to check how fast can it go. Notice that the faster it goes, the quality of the animation is lower and lower. Yeah, which means that this is actually not a very good, not very good as a game engine. It's a good learning tool, but you wouldn't be able to sell the games that you would produce in this framework. A nice thing to have now would be a speed down button, right? So let's add that. Or actually slow down, right? Not speed down. And would have a very similar function or method. Where we divide. Sorry, yeah, so let's save this. Let's run. And now we can get it very fast, and then we can slow it down. And we can slow it down very, until it's very slow. Another interesting thing you can do, which we will take advantage of later, is speed it up differently on different axes with random amounts. So instead of speeding up exactly by 2, I would speed it up by a random amount, right? So for that, oh, I don't know why I'm pressing here. I want to go to documentation and see a place where I can search, and I want random choice, random int, random uniform random. So most of the standard packages are right. So random will give you results that are between 0 and 1, not including 1, right? So 0 is possible, but 1 is not. Yeah, we were here. So instead of multiplying by 2, I'm going to multiply by, I want it to be a speed up, so I want it to be at least 1. 1 plus random times 3. And the same, 1 plus random dot random times 3, right? So now the speeding up is not going to be uniform. It's going to be two different values for the two different axes. All right, and we can do exactly the same thing here. And of course we have to import random. Okay, so now I can speed up, and notice that when we speed up, the angle is not necessarily 45 degrees anymore, right? It will go at a random angle because the result of two random increases on the two directions. All right. Okay, so all this is pretty cool. Are there any questions so far? No? Okay. So hopefully you have all managed to get this code. Let me obstacles. What do you mean by obstacles? You can unmute if you like and explain. I am going to take this and send it to everyone. So this becomes a very simple way of sharing code because now I'm sending it to you and you can all access it. And if you haven't managed to keep up, you can just see it running right now. So if you click on the link, this entire interface is going to open. You can press run and see it run. Yes, of course. I mean, like, I am going to get to the point of you know, making a game. That's the plan for this class. Um, the circle avoids how? It bounces off it, or um, sure. So let's try to put put an obstacle in the middle and have the bouncing thing happen. So what would be interesting, for instance, is to add another button like frame dot add button and say obstacle, and we're going to have the set obstacle. All right. So what's going to happen when we do that, right? So we're going to have here an obstacle flag, which initially is false. And we're going to have a event handler set obstacle def set where we're going to set obstacle flag to, or we can do something even more interesting. Let's say toggle obstacle. And we're going to have toggle obstacle here. And let's call this toggle. And we're going to say obstacle flag equals not obstacle flag. I think actually this needs to be like this, not. All right. So one thing we're going to do is draw, say a square in the middle of some size. So let's define the obstacle size. So obstacle center equals, and we're going to start that with divided by 2 and height divided by 2. All right. And obstacle side, and let's say we have a side of 50 pixels. All right. And inside the draw function, right, we're going to worry about drawing the obstacle first, right? So if obstacle flag, how do we draw a square? We draw a square going back to the graphics modules. We have canvas draw. Oh, there's no drawing of a square or a rectangle. So I have to draw it as a polygon. All right, so we're going to draw a polygon, and then we're going to have a thickness as before, a edge color and an inner color, right? So let us do just that. So in order to draw the obstacle, we're going to define a separate function. I think that is better. So def draw obstacle, and we're going to have corner 1 equals, so we're going to go from the center, right? So we have the center, sorry, obstacle center we called it, right? Obstacle center. So this is the x component of the coordinates, right? And it's the top left corner, right? So I'm going to subtract half the side divided by 2, right? And then also I'm going to have obstacle center 1, right? So this is the x component. And I'm going to also subtract, this is the y coordinate, right? The vertical direction. And I'm also going to subtract obstacle side divided by 2. All right. So by the way, I'm using lists here. We can use tuples. We worked more with tuples. It's usually better to use tuples. There's no significant difference here. So this is one corner. We're going to have 4 corners, right? So we're going to have corner 2, 3, and 4. And then we have to have all the combinations, right? So let's say the second corner is the top right one, right? So I'm going to have a plus here. The third one is the bottom right. So I'm going to have a plus and a plus. And then the fourth corner is the bottom left. So I'm going to have a minus and a plus, right? So we have to have all the combinations of plus and minuses that we can have. And then we're going to have a draw. I'm going to pass a canvas in here. So I'm going to have canvas.draw polygon. Yeah, I think that's what it is. And then we have the list of corners. Right, then let's do a thickness of 10. Let's make it more interesting. Let's get a color of blue and the inner color green. Yeah, I hope that's it. Yes. All right. So this should be it. So we're going to say if obstacle flag, we're going to draw obstacle of canvas. All right. So now we should be able to see the obstacle, right? It will not be an obstacle. We're just drawing it. So if I run this, height divided by 2. So if I draw this, if I toggle the obstacle, I'm going to see an obstacle in the middle. Yeah. And let's speed up. And you see that the obstacle doesn't do anything, right? I can toggle it. I can have it printed or not printed, or drawn or not drawn, right? It probably should be bigger, right? So let's do the side of the size 250 maybe. I think that will make it more interesting. So when I toggle, yeah. All right, and we see clearly that there's no bouncing, right? So let's make it bounce now. So whenever we are so actually we can go inside here, right? So we are bouncing on the sides of the viewport, right? How can we detect that we are uh, uh, near or touching the um, um, touching the obstacle, right? So we have several ways of touching the obstacle, right? So let's say we are at the left of the obstacle, right? So we're going to say or here, and we're saying that center center 0, right, which is the x-axis, is less than or equal, or sorry, greater than or equal to so what do we have here? Should be greater than or equal to obstacle center obstacle center it is, right? Obstacle center 0. I'll tell you what, let's not write it here because it's going to be a complicated one, right? So let's define procedures for this, right? So we're going to say def ball touches obstacle on the left, and we're going to do in a canvas here, no. And we're going to have the following conditions. We're going to have global obstacle, so we're going to have center obstacle. Actually, yes, global center, obstacle center. What else is there? Radius obstacle side. All right, and what are the conditions for bouncing, right? So we have to be very careful here. On the right equals center 0 on the x-axis plus radius is greater than equal to obstacle center minus obstacle side divided by 2 right? So it has to be on the right, just touching, right? But it hasn't, so it shouldn't have gone beyond, right? Not yet through is center 0 minus radius is less than obstacle center plus obstacle side divided by 2. And then not above or below is equal to center so center 1, which is the y coordinate, and then I'm going to have the top of the obstacle, so obstacle center minus obstacle side divided by 2 is less than or equal center, which is also less than or equal minus plus obstacle center 1, same here, 1 obstacle center plus obstacle so we're returning on the right and not yet through and not above or below, right? So this will tell us whether we need to bounce off the left side of the obstacle, right? So we're going to say if center less than radius, right? If this happens, right? Or another condition for changing direction is or ball touches obstacle on the left. So now we should be able to see bounces from the left side of the obstacle. So let's see if that works. What did I do wrong here? Types for sub, list and float. Obstacle center 0. I think. Same thing. All right. I want to push this up. So there's already something strange there. Um, let's see if we get it to bounce from the left side. It's more like a refraction. So let's speed it up. Okay, so it does bounce correctly off the left side, but it behaves a bit strangely on the other side. So we need probably to strengthen the condition to avoid that. Oh, we are having bounces from the right side as well, which is strange, unexpected. All right, so let's try to correct this. All right. So when we are on the right, so it's correct when we are on the right. So if we coming from the when we are on the left, so this should have been called on the left actually. So we are at center 0 plus radius is greater than obstacle center 0 minus obstacle side, right? And it's not yet through, so center 0 minus radius is less than obstacle center 0 So this is very strange because we're only changing, or wait, we're only changing Vx, and this should be true. So center 0 minus radius less than obstacle center 0 plus obstacle side divided by 2. And obstacle center I think so. I think actually this is correct. Just that we haven't. We need to take care of all the other four sides, and then it's going to become correct, right? So we need to stick for the time being with the fact that it actually bounces correctly from the on the left side. Yeah. So again, if I uh, run, this should be on the left. All right. So if I run this, um, there's another thing another mistake that I made, right? Um, so I should um, qualify this the with the flag, obstacle flag. So if obstacle flag and, all right, and then I can close this here, and then this will run correctly at least. So when there's no obstacle, it will run correctly. I can toggle the obstacle, and then strangely it bounces correctly on the right side as well, unintendedly. But then it has this strange refractive. All right. So if I add conditions for up and down, I will just get it to work correctly. All right. So let's try to do that quickly because we don't have a lot of time. So ball touches obstacle on top. And then this is going to be symmetric. Yeah. So on the left, so it's going to be on the on top. There's going to be center 1. We're going to change to the Y direction. Obstacle center 1 minus obstacle side, right? Not yet through, center 1 minus radius, obstacle center 1 plus obstacle side divided by 2, and then not on the left or right. Is obstacle center 0 minus obstacle side less than center 0, obstacle center 0. And then we're going to have all these. Not yet through has the same name. Not on left or right goes here. All right, and then going inside here, we're going to take this and add it here. But this is the new function. All right, and let's see how this one works. Okay, so now it works fine. Is this what you wanted? Cool. Okay, so we're gonna start working on the game next time because this is all the time we have tonight. Uh, Let me send you the link to this one. All right, and have fun with it. Any questions? So just for your information, this is a very nice thing to remember whenever you want to do some coding. All you need is a browser. You can do it from your phone. Um, yeah, and the animation would work on your phone as well. So no need to install Python. No need to go through a lot of pain. Just open this website and start coding. This is yet another fun way of learning Python. Cool. So I'm going to stop here if there are any questions. I think tomorrow we're going to do the same thing. So we're going to have a e-learning class. I will resume physical classes at some point, so stay tuned. So maybe next week, because I'm guessing that you will have some questions at some point, and you need them answered. And then next week I can also stay after the class and answer as many questions as you need. Um, the before we go, there's one thing that I did want to show you, which is the game we have developed last time, right? So there is a link for it, but so it's interesting that um, we can what was I going to say? I lost my train of thought. So it's a very classic game called Asteroids, which for some reason, um, yeah, this is not the best version I've had. I've had better versions. Um, but it's a spaceship shooting at asteroids and destroying them, and then we're gonna develop the same thing, and then assignment 4 will be to um, to develop some extra features. I'm trying to get it destroyed. Okay, and it doesn't get destroyed. So unfortunately, I don't think I brought the best version of the game that I have ever had. Um, yeah, just be careful. What the homework is going to be based on what we end up developing in class ourselves, right? So don't mix them up. Why do I keep getting here? So let me try to put the link to this. Okay, it's here. Um, okay. Cool. That's it. Enjoy your weekend. Actually, no, there's a class tomorrow. There's not weekend. It's not weekend yet. So I'll see you tomorrow. Then in class, we're going to start doing the game. We're going to learn a little bit more about this framework, how to load images, how to move shift things around, how to control stuff from the keyboard. And it would be good if you try to remember a little bit of your geometry that you learned in high school. learn or remember about coordinates, sinus, cosinus, those trigonometric functions, and so on, because they're going to be used in uh, that piece of code. Cool. See you tomorrow. Take care. Stay safe and healthy. Yeah.